So yeah, today I'm going to talk about containers and virtualization for the HPC cluster, which I think is very relevant for the topic today. But first of all, I will introduce myself. So I'm a system engineer. I started working as a developer. Then I worked for more than 12 years as a networking engineer. And now I'm working as a DevOps for the last 4 years. And in the ETH Zurich, especially, I'm doing HPC/Kubernetes engineer there. So yeah, let's start.
Nicolas, just a question. Can you switch on your camera or you don't want so that we can see?
I'm sorry.
You all? Would be nice.
Perfect.
Yeah, so welcome.
I'm also going to switch my, give me a second, to my microphone. It's probably better.
No, that was already very good. So that would be.
Maybe it's better now. The audio is better quality, probably.
It's the same. I have the impression it didn't change.
So anyway, so yeah, let's start with the presentation. So my presentation today, it's pretty much on the infrastructure side, so not too much on the user side. Just for the user side, we have Singularity containers, and we also have some VMs as login nodes that we use in a medical research tenant that we have. I will get deeper on this later. But that's pretty much on the infrastructure side. So in our side, infrastructure side, this story goes back to the beginning of 2020. So we were all working in shared offices without any mask back then. Using a mask will make you look very weird, actually. And the clusters, HPC clusters, were not being targeted by hackers that we know. And our security concept was the old school good firewall, SSH keys. And the infrastructure was the result of years of organic growing. So we have a mix of technologies. Some services were running in single hosts, some others on VMs in VMware, some others on VMs on OpenNebula. It was a very complex organization. We were also testing some new technologies, like we're running some services already in containers. So Docker Compose style containers, we call it solid base back then. And we also had Kubernetes proof of concept at POC. We also had another Kubernetes cluster, but more for web apps, for services like the chat or the netbox, which is an IP database management. But we had a lot of ideas on how to improve all these. So we were talking a lot, mainly in the kitchen, how this should look like. So let's say if we have to start from scratch, how do we rebuild everything? That was a recurring topic back then. And yeah, one day, this, maybe you already heard about this, but this attack against multiple HPC sites, it seems that some people wanted to mine some Bitcoins. And yes, we were also affected, and we decided to not trust any of the existing infrastructure. So the safest thing was to start from scratch. So we had to recreate or reinvent everything in a secure way, much safer than before. Then the question rises, so what do? We rebuild legacy, so we rebuild what we had before, or we go full with our improvement plans, with our crazy ideas, let's say. So we have to reinvent something that scales, that is safer than before, that is robust, and if it's possible, something that is highly available, or even that's self-healing and whatnot. And yeah, we had the hands-on, and that was 2-3 months roughly of just working all the time. We had no weekends. We just eat, work, sleep, eat, work, sleep. Maybe going to the bathroom sometime was allowed, but then it was just work. And we did it. Yeah, we managed to accelerate this transition we had in mind, and we bring this new concept of Kubernetes as the brain of the infrastructure, as the brain of the data center. So we decided to implement this microservices structure, right? So which is, for them who don't know, is a style that structures an application as a collection of services. And every service must be highly maintainable, stable, reproducible, and independently deployable. That's important. And how do we provide these microservices? Of course, as you all know, we use containers, which is a standard unit of software that packages up code and all the dependencies that they need. So what is important here, that if the container runs on your laptop, it also runs on the server, and it also runs in my laptop. So that comes with a lot of benefits. But the problem starts when you have a lot of containers, right, to manage. So you have 15 or 60 containers. Then how do you manage all this complexity? Because one container depends on the other, or one is allowed to talk to the other, but not to the third one, or stuff like this. So then you need to orchestrate all these. You need health checks also for the containers and so on. And for the orchestrations tools that we already know, the de facto tool is Kubernetes, which is high available, it's easy to automate, the replication is declarative, so you write a YAML file on how do you want your deployment, and Kubernetes makes as much as possible to make this happen, right? If something fails, it restart it again, so it comes with a lot of benefits. And as you see on the screen, we create the receipts for all of these deployments. We have a base stack with all the netboot, repository, DHCP, DNS, and so on. The list is huge. We also have console here that we use for health checks for the nodes. In another cluster, we have the core services that, among others, we have Vault that is in the way to get to zero trust security approach, that we can get short-lived certificates to administrate these things. And then we have a multi-tenant cluster, but I will get deep on this later. But the important thing here is that we can replicate, so we can redeploy all of these much more easy than before. And let's say if we are hacked again, because you can never discard that, it will be only a fraction of time and energy to recover from that. So we have a disaster recovery plan much more healthy, actually, much more faster. So where we did apply these receipts, and what is a receipt? So a receipt is pretty much, you describe how you deploy an application. And for that, you use Helm and Kustomize, right? And we have mainly two big clusters. So we have one cluster, which is Euler, that is now being integrated with Leonard. So let's call it Euler for now. And it's more than 110,000 cores, which is a classic HPC from the user's point of view, not from infrastructure point of view. But then we have Leomed, which is this medical research secure cluster. And this is a special case because it supports medical research. And like the genome guys before, we have also super sensitive data here. So it has to be as secure as possible. So let's take a closer look to Leomed. In Leomed, we have coexisting user-facing VMs and microservices, right? So we need VMs here because we need this virtualization isolation, which means this isolation resides on the impossibility or the difficulty, extremely difficult to get out from a VM to the hypervisor. That's where all the cloud providers base their service, right? So every tenant that we have is an isolated tenant. It's network-wise and hardware-wise. So we don't have any shared host, actually not host, but machines, workers, or login nodes between tenants. So we prevent from the side attack channel from this. So this attack that someone could read the CPU cache and see what is your neighbor doing. So we prevent from that, but not sharing hardware. And network-wise, it's isolated because every tenant have a different VLAN, a different virtual local area network, right? But then the problem is how we deploy VMs then. What we use, how do we automate and operate with limited human resources, because we are not a huge team, we're just a few people working on this. So then the answer we found was pretty obvious when we read the official KubeVirt description is KubeVirt, right? So KubeVirt is a software that is developed by Red Hat, and now they open source it, and is the official virtualization platform that they deliver with OpenShift. OpenShift is a flavor of Kubernetes that Red Hat sells and develops. So if we take just a fast look on the description, the KubeVirt technology addresses the need of a team that have Kubernetes, but they still need or want to use virtual machines. And the good thing about this is it produces a unified development platform. So everything is Kubernetes. But let's take a deeper look on this, because how this is possible. How can a VM run in Kubernetes? So basically, what these guys did is they wrap a virtual machine inside a container. So the classical way, how do you run a virtual machine in Linux, is you use KVM plus QEMU. which is a super old, not super old, but a very well-proved technology to run in virtual machines in Linux. So they wrap all the dependencies inside a container, and they put it inside a pod. So I will explain what is a pod. A pod is a Kubernetes terminology, and it means one or more containers that provide a microservice, let's say. So as you see in the image, you have your stack, your bare metal OS, and then your GUI runtime, which could be Docker or Podman, doesn't matter. And then on top of it, you run microservices, so containers. And inside a container, you have a VM. It's just another container. And this comes with a lot of benefits because what about the other pods, right? So what happened? You have, let's say, the DHCP server running in a pod, in a container, and then in the same host, you could have a VM providing another service, right? And it doesn't increase the complexity of it because we don't need to have yet another technology or another platform to run our virtualization platform. So the good thing is everything you develop or implement for your Kubernetes cluster, you're also doing it for your virtualization platform because it's the same thing, it's the same API, right? So if you have storage, you have a networking integration, you have alerts, you have monitoring and so on, you have user authentication, for example, everything you do for Kubernetes cluster, you're also doing for your virtualization platform. And then this is pretty technical detail, but I think it's important to understand the complete picture. And is how can we have a foot on different VLANs? So how can I deploy a VM inside a container inside Kubernetes, but this VM lives in a specific VLAN, in a specific tenant? And for that, we use Multus. Multus is a CNI, which stands for Container Network Interface, and its specification to configure network interface in containers. So basically, with Multus, you define a specification, which let's say this NIC, it lives on the VLAN 113. And then when you run a container, you say, okay, these containers use this specification. So the container only sees this NIC, only sees this VLAN. Actually, if you describe the container, you could see more interfaces, but the VM inside, it only sees this NIC, which is safe because if we trust on the virtualization isolation and we put this on one VLAN, then we can assume that is as safe as possible, right? So the benefits of this stack of running Kubernetes plus Multus, which is the CNI that allows us to put a pod in a VLAN, plus Qubit, which allows us to put a VM inside a pod, is that, of course, the main one that we have only one API, only one thing, which just manage a Kubernetes cluster, nothing else. So it inherits all the benefits of running something in Kubernetes, like explained before. It's extremely powerful, innovative, it's easy to automate and operate. It attracts talent also, because if you want to hire someone to work with a 20-year-old technology, maybe you find it still difficult. If you want to hire someone that wants to work with Kubernetes, probably you find it easier. You can do also live migrations. If you have one node that it has to be reinstalled or wherever, you just live migrate your VM or your pod in Kubernetes. It's quite simple and it's meant for that. And the user doesn't see anything. It's transparent for the user. And the community behind Kubernetes, Multus, and Qubit, and all of this stack is huge. It's probably the biggest community in open source, probably among with the kernel Linux. It's a huge community. And another thing that is that we can implement this because we had the know-how, because we were already doing some POC on Kubernetes and using this approach. And also, one important thing is that you may think that, okay, these things looks very new, it's probably too green, but it's actually not. It's very well proof, and the adopters are, among others, is Apple, Cisco, Clover, NVIDIA, and the list is growing, and so big players are already using it in production, right? So what about automation? Like in Kubernetes, because of this huge community behind and because of the huge environment that is around, you could find a software development kit, so SDK, almost in any language the popular ones at least, you can find one. So Golang, Python, C, C++, wherever you like to use, you can find a software development kit. In our case, we use Python because it's the system, so the language we are using internally in an HPC at ETH. And what we did, mainly we started by creating new tenants because this process took around 2 weeks because it's touched different internal groups and one depend on the other, and then you have a bottleneck and stuff like this. So it was taking roughly 2 weeks to create a tenant. And after we automated this, we can do it in 20 minutes. And it's 20 minutes because we have to clone the base image because this is a stateful VM. And we also have to contextualize this VM with the configuration management that we use, cdist. And this takes some time, but the manual things is everything is automated. And we can also retrieve information with this CLI that we create. It's called tenantctl. And on development, we had continuous deployment approach. So if you want to change something that is running on this ecosystem, the idea is that you just change a config file or change whatever you have to change, and then you just git push, and then the rest is automated. The rest is we're playing with Argo CD to automate of this. So for example, if you want to add a new list for the DHCP server, you just put the list, put the MAC address, the IP, just git push, and then Argo CD will restart the server, pick up the new configuration, and make sure that everything works right. Another interesting idea we had is to provide over clusters, so which is a Kubernetes clusters that run inside the Kubernetes cluster, and this is for providing this to the users. It's an idea to give a user a Kubernetes cluster. So it's very often that these days users in a HPC world, they are asking for a Kubernetes cluster to run X wherever. And it was not so clear how can we do that, but in terms of security, the best thing is to provide an entire new Kubernetes cluster just for them and not share the Kubernetes cluster you're using for other stuff. You have this namespace isolation, but it's kind of under discussion if it's super safe or not. So we did a lot of things in a very short period of time, and we learned a lot of stuff here. And one of the main things is that it was not only a technical change that we did, because some technologies also comes with a culture revolution, right? So we did, people need time and training to shift to this culture. And this is difficult if you're already 100% busy. So we still have unfinished things. We are still working on reliability, on logs, on metrics, alerts, backups. It's a complex technology that a complex service that we deliver, and there's no way to make it as simple as it is. So there's still things to do. There's also these day two operations that we have to live with. And so mainly, for example, you have to update a Kubernetes cluster every 6 months because then they only retrieve, they only do security releases for the last 3 versions of Kubernetes. So if you don't update it, you will end up using a not maintaining any more version. Also, if you don't do anything for 1 year, your certificates will expire. Your SSH certificates that they used to tag between the nodes, they will expire, and then the cluster stop working. This is not a good idea. So better you keep an eye on it. So it's the day 2. It takes some time. We also have still a lot of ideas that we wanted to implement, and we go one by one because some that are super interesting, at least for me. We wanted to run the LSF. I put it here LSF/Slarm because we probably start using Slarm. Now we are using LSF, it's not clear. But we are running the masters for Euler on bare metal machines, and for Leomed, we provide a VM that runs this master inside. So it's running inside Kubernetes, but it's a VM. So we are paying this overhead of having a VM, and it's not necessary. We could wrap all the LSF master inside a container and just run a container and not a VM, and it will be more efficient. We also want to do the same with the login nodes we don't need to run a VM for a loading node. We could run as a SSH server and bash inside, and it could be just only one container. That will be even more efficient. Another idea we have is to run all the workers also inside a container, which means we could wrap all the LSF worker or Slarm worker inside a container, and then instead of having a 5 nodes Kubernetes cluster, we could have a 3,000 nodes Kubernetes cluster with all the workers inside. And when we deploy a daemon set, which is basically run this service in all the nodes you have Kubernetes, and this deployment will be the LSF worker. So then we will get for free all the benefits of Kubernetes, like for example, health checks. If some worker fails, Kubernetes automatically take out of the cluster, and it doesn't send more jobs to this worker. These days we are doing this with Consul and with other scripts and stuff, but it will be more clean if we can do it with Kubernetes because it's meant for that. Another idea we have also is to run Falco, which is a security software that runs inside Kubernetes that will improve even more the security. We're running Calico, and we are also exploring the network security features that it comes with it. It's an eBPF security. It's like the update of IP tables. And then, of course, the one I mentioned before, the Kubernetes on demand. So users want to run something in Kubernetes, so we can create another cluster and provide this to the users. So that's pretty much, among others, a few ideas we have under consideration. But before, of course, we have to finish all the things we started after the hack. And yeah, we are still fighting this battle. It's not easy. But I think we have now future-proof infrastructure, let's say, and it have a lot of potential. And yeah, we are quite happy what we did, and I think it's going to keep like this for a few years. So here I think we have 9 minutes for questions. But first, I wanted to give some credits to Stephen Armstrong. He's an impressive engineer we have in our team. And he was working with me to develop all this. And so thank you, Stephen, because this was possible only because of your very good skills. So now we have time for questions. So please raise your hands.